This video is to help you understand how to put numbers in scientific notation. Scientific notation is really used to write really big numbers or really small numbers in a way that is easier to understand their value. Because instead of looking at counting tons and tons of zeros, all we have to do is look at the exponent to really understand how big or how little the numbers are. So what I've done is put a couple of rules here and steps that you can follow to put a number into scientific notation. So the first step is a really easy step. Step 1, place the decimal on the number if it is not already there. So you can notice in this first number here, 653, the decimal is not there, so we know anytime there's no decimal there, it always goes at the end. So we put our decimal right there, 653, then the decimal. The second number, 0.025, the decimal's already there, so really we get to skip step 1. Moving on to step 2. Move the decimal after the leftmost digit. Sometimes this wording confuses people. So if you look at the number 653, think about the leftmost digit. So 6 is the digit that is to the left, furthest to the left. So we want the decimal to move after the 6. So that's why down here, the decimal went from back here to after the leftmost digit. So now the number is 6.53. It's after the leftmost digit. Now, in the second number, it's a little bit different. Zeros don't really count as an actual digit. It's really just a placeholder. So 2 is really our leftmost digit. So we want the decimal after the 2. So that's why down here, the number has moved from 0.025 to 2.5. The zeros just drop off since they're in front. So that's step 2. Next step, we write after the number times 10. So we have written 6.53 times 10 and 2.5 times 10. That's very easy. All you have to do is write times 10. Step 4. You find the exponent by counting the places you have moved the decimal. So in this first number, the original number was 653, and the decimal was originally there, and we have moved it 2 places. So that's where you get this exponent of 2. Notice that our original number was a big number. So that means that our, or bigger than 1. So that means our exponent is positive. In the second number, our original number was 0.025, and our number was less than 1, or a smaller number. So that's why when we moved it 2 places, that's where we get this 2 right here, but notice it's negative. And that is negative because our original number was less than 1. There are also directions up here about if you move it right or if you move it left, which is good, but it's a little bit harder to memorize right and left versus just look at the number. If the original number is greater than 1, then it's a positive exponent. If the original number is less than 1, then it's a negative exponent. So let's do a couple of examples here. Here is this first number, 1,345.8. So our first step is to put the decimal there. Well, it's already there, so we don't have to do that. Second step, we're moving the decimal after the leftmost digit. So 1 is our leftmost digit, so we want our decimal point there after the 1. So we're going to rewrite it as 1.3458. Step 3, write times 10. Now we have to count to find out what our exponent was. So we moved it 1, 2, 3 places. So I'm going to put a 3 here. And our original number was greater than 1. So that means my exponent is positive. Let's look at this next example. We need to put our decimal in. It's already there. We don't need to do that. We need our decimal after the leftmost digit. 1 is our leftmost digit, so we want it right there. So we're going to rewrite it 1.24, sorry, that's not a very good 2, times 10, and we moved it only one place, so we could put the 1, but since our original number was greater than 1, it's going to be positive. Now, if our exponent is a positive 1, we can choose to put it, or you can leave it off. Either way is fine. Okay? But if it's a negative 1, you have to put it, negative 1. Okay, next one. Our decimal's already there, so we don't need to add it. We want to move our decimal after the leftmost digit. Now remember, zeros don't count as digits, they're just placeholders. So our leftmost digit is actually this 9 right here, so we want our decimal right there. We want our number to read 9.045 times 10. And to figure out how many places, we moved it 1, 2, 3. And notice our original number was less than 1, so it's going to be negative. Same down here. You can already tell our number is less than 1, so we're going to have a negative exponent. Here's our leftmost digit, so 2.31 times 10. And we see how many places we've moved here. 1, 2, 3, 4, 5. So we're going to be negative 5. So the way you would read this number is 2.31 times 10 to the negative 5th. And that is how you put numbers in scientific notation.